Hi, welcome to lecture 3.3 of the Monte Carlo methods course based on Sage. We will see Bayes' theorem and some examples and its applications in this lecture. We just saw that the probability of B given A, that is the conditional probability that event B will occur given that event A has already occurred, is defined by probability of B intersection A divided by probability of A. By using the fact that B intersection A is the same as A intersection B and reapplying the definition of conditional probability to probability of A given B equals probability of A intersection B divided by probability of B, we get the so-called Bayes' theorem. So the Bayes' theorem is as follows. Probability of B given A by definition is probability of B intersection A over probability of A, and that is nothing but probability of A intersection B over probability of A, and that is nothing but probability of A given B times probability of B divided by probability of A. So we've done nothing but use the definition of intersection, the commutativity of intersection B intersection B. A is the same as A intersection B, and then we simply once again apply the definition of conditional probability to A intersection B, and we have now what's called the Bayes' theorem, namely the probability of B given A is the probability of A given B times probability of B divided by probability of A. Here's a try for you to do at home. Suppose we have a bag of 10 coins. 9 of the 10 coins are fair, but one of the coins has heads on both sides. What is the probability of getting 5 heads in a row if I picked a coin at random from the bag and flipped it 5 times? If I obtain 5 heads in a row by choosing a coin out of the bag at random and flipping it 5 times, then what is the probability that I have picked the 2-headed coin? Okay, so this is a very nice application of Bayes' theorem. So you should try the solution by yourself first. If you can't, or you want to actually follow through the solution, you can watch the Khan Academy movie about this, and this one is quite nice, and it's about the application of conditional probability and Bayes' theorem to this bag of 10 coins, where one of them is a strange two-sided, two-headed coin. Okay, so please go to the worksheet and play this video like that, and you should be
now our probability problems will get a little bit more interesting. So let's say I have a bag full of coins.
This is Khan.
So this is my bag of coins. Maybe it's a bowl of coins. So I have a bunch of coins in there, right? I didn't need to draw it, but I did anyway. And let's say that I know that 9 of these coins, 9 of them are normal. So what do I mean by normal? It's just, let's say they're quarters and they have a heads and a tails, and that there's a 50% chance of getting a heads or a 50% chance of a tails if you flip any of those coins. And then one of the coins is a two-sided head coin, two-sided head.
Alright, I'm not going to go through this and embed videos inside videos. This is for you to do on your own. Okay, here is another. Play this as well.
So let's think about what we did in that last video, and maybe drew it in a little bit more of a visual way. So let's say this rectangle that I'm about to draw is the set of all the things, all of the things that can that I guess can happen. It's a set of all of the outcomes, right? And we know from the get-go, and we're still doing that same.
Okay, so this is just another way of really understanding that problem with 10 coins in a bag. And finally, this video is also very nice. So you should watch
the last
all
video,
3 of these videos.
I hopefully proved to you, at least, maybe it doesn't make intuitive sense just yet, But I showed you, that the probability of A and B is equal to the probability of A given B times the probability of B.
Okay. Of course, you don't have to go through these videos because all the material is already given to you outside the videos, but the videos really help reinforce ideas in a more interesting way. Now, let's get into further U tries. Okay, so here we're going to actually get into Sage now. So the next cell uses a function called randint. Okay, randint is a built-in Sage function, which we will talk about more later in this course. For this week, we'll just use randint as a computerized way of rolling a die. Every time we call randint 1, 6, we will get some integer number from 1 to 6. We won't be able to predict in advance what we will get, and the probability of each of the numbers 1, 2, 3, 4, 5, and 6 is exactly the same. Here we use randint to simulate the experiment of tossing 2 dice. The sample space capital Omega is all 36 possible ordered pairs 1, 1, 1, 2, ... 6, 5, and 6, 6. We will print out the results for each die. Then we will try evaluating the cell several times, and we will notice how the numbers you get differ each time. Okay, so this is a U try. Go ahead and just ask what randint is all about by putting a question mark after it. So now Sage's help menu should load, and we get the help. It says the doc string says return random integer in the range A to B, including both endpoints. The definition is randint of A, B. A and B are parameters passed into randint function, the built-in function, and here are some examples. So let us, or I'll let you try. Like that. So die 1 is 4, die 2 is 4, and die 1 is 4, and die 2 is 5 this time, and it's 5 and 4 again, and it's 3 and 1 now, and it's 5 and 1, and so on. So we have an idea of throwing the dice in the computer by calling randint. Okay, so play around with that. The next topic is going to be random variables. Okay, so this is a good time to pause the video, go back through all of this simulation and these videos if you have the time to watch to reinforce this little example, Bayes theorem, conditional probability, and all the way to the very beginnings. Make sure you understand the domain of the probability function, the sigma field, and the implications of the axiomatic definition of probability on them, and what is the definition, and so on. So this is a very good time to recall all of these ideas, because now we're going to move to a different topic called random variables. See you in the next video. Okay. Bye.